makeup is different. So we built an extension. It worked. It was kind of cool. We instead of making a real wall, it's basically a cube that you could change its attributes in scale and in position. And then we have a reset button that sets everything back into basically deletes it. So that worked. It felt great. It also felt a little intimidating for me as to, okay, what is the next step? Because I want to build something very particular, as I have written down here where the challenge 2 and challenge 3 are, which is really extending beyond walls, and then we can make windows and doors and so on. But I also felt like it was a little, I didn't quite know what I was doing. And really I was following step by step from another tutorial video, that was really greatly made, and it gave me a lot of confidence, but I have to be honest, I didn't know what I was doing. So that led me down to a rabbit hole of really digging into Omniverse's code. And the way I found that code, which, absolute applause to the Omniverse team, was every time you open up any of their apps, I say, okay, this is the launcher that I have opened up. Say you have a code app, I have a code app, I have a Kit app. You could actually come in here, say, I clicked on the Kit app. I could come in here, go into setting. I think it was setting. And here you would find the installation path. So if I copy this whole path, well, I clicked on it. If I clicked on this whole path, I could find where this whole thing is. Essentially, I have the source code for Kit. Isn't that amazing? It's crazy how I mean, I knew that it was open source, but to see all this resource lying here for us to just explore, it feels unreal. It feels like I'm back in my FreeBSD days, where I could actually look into how people wrote their operating system and taught me how to really, the concepts of what includes in a very high level organizer. So, and that is what oftentimes people call, in an operating system at least, they call it a kernel. And Omniverse, the way I see it, is the operating system that has the potential to be decentralized, but also very much cloud-based, of an operating system that is for everybody. So being highly inspired and really intrigued by all this resource, I open it up in Visual Code, like how I would do in any other app, and I would show you this here. I wish I could I remember the keys to expand the fonts, but this is it. What you see up here, Kit 104.2.0, is the source code that I found. Well, that was here. So now we have a ginormous opportunity ahead of us to truly learn what the developers were thinking, and how basically this is, if I'm a musician, this is my window into seeing into the composer's mind. What foresight are they planning ahead, and also what they see Kit to actually be. And now I'm no expert in C++ nor Python, but from a high level I could understand structure and connect the dots of what it's trying to do. Before we dive too deep into it, which I do plan on doing it in this episode, because I feel like there's so much value in this that I think it would be a shame to not just honor it. It's more like, we got to learn what everything is, but we also got to learn why they're there. And so instead of diving deeper into the next logical episode in the manual, where we dive deeper into the extension, which is this extension advanced page, I want to dive deeper into IApp. Essentially, what 2 pages ago we were talking about the Kit core, and with that Kit core I created this diagram, which everybody is welcome to go back to. And this is just literally reading things line by line from this manual. But when I'm looking into the code here, I'm seeing literally what they're talking about. Like, it's not just an abstract concept, it is an executionable task and function that they were creating, and how this plays into excuse me, the role that Omniverse is giving Kit. Now, on their jumping sort of, we'll come back to that in a little bit. This is another manual of Omniverse, where they happen to, and I couldn't find this page unless I Google it, literally type in Omniverse Structure, excuse me, And this is also one thing that we could probably do better in the documentation. And again, no fault to their own, but I would probably, down the road, I would probably do my version of how I could understand Omniverse's documentation from sort of an outside eye. I may post it on Medium. I don't know exactly where I'm going to do it. It might stay in a Figma diagram-driven document, but I also think that there's value in putting it in a sequential sort of blog post style context, so format. So we'll see how it goes. But I kind of want to replan this and replan this so I could have a so I could personally trace back to it and you sort of make things make sense to people that are not only developers. So in this page, I did find that there was quite a bit of good explanation as to where Nvidia sees Omniverse. And I think, like, the term says it all. Like, it's an all-encompassing environment where many things could happen. So it's a little bit hard to describe it to normal folks on what is Omniverse, right? But that, at the core, I think it's a 3D ready operating system that allows things to be could sit on a local computer, but it could also sit in a cloud. But it's an infrastructure that allows 3D operations to be had, and that includes, in other words, to mimic things in 3D, which could be said that we're mimicking the real world. You need to have physics, and this is why I think, in this chart, in this Kit stack chart, it is organized in such a way, and Kit is at the very bottom. I understand that this may or may not represent a hierarchy on a vertical sense, but I do think that there's a reason why they put Kit on the very bottom, and all the physics and the visual representation, which is the ray tracing engine, down on the very basic, fundamental, or foundational level. Now USD is also included inside Kit, because one could argue, and that's all. Basically, I think it's not curious, but it's interesting that they included USD inside the Kit instead of in a core extension. In other words, they see USD as a language, or I'm interpreting it that they see USD as not only as is it essential, but it also is highly tied to how we interpret the real world. I am instinctively finding it close to the concept of time, and that is because you have the material world where you handle all the physics. You have the perception, which is whoever, if we talk about really I guess you could say theoretical physics theory, then you have the material, the mass, and the speed and all that comes in the physics world that talks about mass and all the laws of physics. And then you also have the person that is seeing it. So the perspective matters. If you see it from this point of view and another point of view, sometimes time is different. If we really talk about theoretical physics, and then USD to me sounds like the concept of time, and which I find very, very interesting, because in this we are talking about layers. In USD, at least there's a concept of layer, and I do think that there's a layer in time. Okay, enough of that. These fun talk. But as you can see, that texture, mesh, and content is not inside Kit. In other words, down the road, they see, like, say if we adapt a learning algorithm, aka AI, into this will most likely be less, like, it would be unchanged, basically. Whereas this content, mesh, texture, that is, namely core extension, it is part of the core, it is very close to the core, but it's an extension, meaning that it is not the core. It is not the basics of physics. You'd be we have the flexibility to separate these two. I think it is important to know what Kit includes and what it does not. I'm gonna change this song. This song's boring. Only the beginning songs are great. Okay. Enough of that. I think I want to really quickly start diving into the code, into the brilliant code that have been written so far. I'm sure it's going to expand. You could tell that it is by design very, not only is it object oriented on the object oriented, like it's very meta, I'm sorry, but it's highly extendable, it's very modular, and everything only has what it absolutely needs and doesn't have much of what it doesn't need, and therefore allows for a lot of extension. And that's why extension is such an important part of it, is that it is what we create. Shameless plug, that's the name of my design company, but we create the extensions, we the people, and this is by design. And I think one of the things that sort of is drawing me to Omniverse, and specifically this solution, the Nvidia Spirit, is because that it's a playground that welcomes everybody. It feels very non-commercial, and it's touching almost. It's a community. It's very human. Ironically, this very, very AI driven, now commercially AI centered company happens to have a very human spirit in how they build their team and how they build their product, because product is nothing more than the extension of the culture of the team, basically, who created the product. Products could be amazing and could have the most incredible technology involved, but it will reflect, inevitably, it will reflect the team culture. And that is how they create, through the lens of this product, I could see the culture of Nvidia, of the team behind it. So that is a tangent that that allows us to come into this code. I think that these are things that I value about, or that I find interesting about code. It's rarely that the code itself, or the beauty of the code itself, mesmerizes me, but I see the human behind it, and that's the beauty, to me at least. So we all excuse me, coffee break, slurp. All right, let's dive into a little bit about the folder structure. Let's start from the beginning. So the moment you open up this folder, you'll see and I will first put a disclaimer out there that I think this is the beginning of the Omniverse. In other words, like this diagram, the Earth or the universe started somewhere, and it's oftentimes not an excuse, but it is the nature of the beast. It's oftentimes messy. Now, I'm not saying that the code is messy, but I'm saying that it's in the middle of a progression. Keeping that in mind, let's look at the structure of the folders. To my understanding, and I might be wrong, whoever that's in the Omniverse team could tell, just shoot me a message on Discord or whatever, or email. You feel free to email me. That this is, I'm completely wrong. You could tell me that. But I feel like this program was written first in C++, and because it has the vision of making it learnable, a learnable environment for machine or for humans. That's why they included Python as a really important part of their approach to this folder. That's why you have the Python binders. Everything has a Python equivalent, but it was first written in C++. And I think, based on the code that I could see, I could tell that the C++ part was very, very, very organized and well commented. Well, there's really good documentation and everything. It's very, very organized. Excuse me. So in order to find the IApp.h, which is basically what this is talking about, the Omniverse Kit Core IApp interface, that whole thing is inside the kernel folder, and I believe it's inside, wait, no, it's not in the kernel folder, it's inside the dev, which I find interesting. I probably wouldn't name it dev, but it is what it is. But it's, this is where you would find it, and if you want to follow along and study it with me, it's inside dev, then you go into include, then you go into the structure of the package, Omni Kit. Get it? So it's instead of going straight into what would look like what you would think is it would be in kernel. Kernel, I believe, holds mostly the Python stuff. I could be wrong, but if you open up kernel, you'll also find one of the you'll find a folder called Py, and then you'll also find a structure of what would look like a package. So Omni, Kit, and then you'll be able excuse me, you'll be able to find app Py, which is basically the Python version of IApp, the app interface, the core app interface. So I have both of these opened here. We'll first look into the dev version, the C++ version, because it was written first, and the Python version is a binder to that. So it's a Python interface into the C++ core application interface. So with that explanation out of the way, I'm going to close this, and let's look at the code line by line. To make things easier, because what I actually want to do, and you could follow, just follow me for a second. A little way back when I just started the channel, I forgot whether it's I forgot who sent this to me. It could have been, I believe it was someone from the Omniverse team, but it could have been Edmar. Edmar, if you're listening, this might have came from you, but this is a brilliant idea. He sent me a link to Unity's documentation, and they had this brilliant flowchart. It's a life cycle of their script lifecycle flowchart, and they had these. Essentially, this is basically not dissimilar to pseudocode. I often find pseudocode much easier to understand on a high level of what it's trying to do, instead of getting too deep into things. So what I want to do is I guess you could call it a life cycle chart of the core app interface. So it'll be something, eventually our end product would look something like this, but for Omniverse Kit IApp. We might do it beyond IApp, we might not, but this is the first step of that. So here we go. We're finally getting into, after all that, we're finally getting into this. So to begin, in Figma, and this is this is a shout out to Figma team and this brilliant tool that they created that allows me to do this. I have copied this whole IApp code into Figma, so we don't have to switch back and forth. I'm imagining that it'll be easier to see for you guys, because I do know that the zooming functionalities is a little different. Like, it's just sometimes it's a little bit small in VS Code. So okay, let's begin. Let's make this large. So here's what I'm gonna do. I'm gonna start by turning off this music because I'm getting a little distracted. Sorry if it sounds boring now, but this is what it is. As you can see, I'm gonna export everything in this diagram out. It may take one or more episodes to do this, but on a high level, I believe we'll be able to complete the core app interface part. So we mentioned, or you could see here, this is all part of Omni, and this is all part of Kit. So on the very top, we have the extension manager, which they call it. Basically, this is, let's see how we're going to do this. I think that's how it's going to be. So this is the extension manager. Does that make sense? I think we need to put our trusty to see what to draw as a process. Okay, I see. So they only drew processes. I think because I read this code already, I'm gonna tell you that most of the definitions is on top, and then there's a slight part of essentially execution down here in the bottom. It's an inline function that initiates the IApp interface, and then it makes it real. So let's drag our little bubble down here. So instead of reading it line by line from top to bottom, I'm going to come down here first, because I know this, we could trace it back to what's happening. Can I bring this up front? Bring to front. Yeah, that works. So we're going to bring these bubbles, all these bubbles, all around the place, and we're going to follow the code. So the app starts up first, as you can see. I will follow the the uppercase, lowercase, because I think it's important. It does this first, then it does a loop. Essentially, this, no idea how that came about. All right, is running. So this needs to happen in a loop. And then last thing that happens is shutdown. That makes sense? That makes sense. And then of course everything is in the IApp. We'll add that IApp part later. So in order to run this, basically, this is funny. So there's also we should make an outer thing called run, because that is what is happening. And I'm gonna do this IApp because it's essentially it's initiating directly from the interface. And I don't even know if it's oh, it does return an integer. This needs to be a different color. Let's make it a blue. Put it in the back, into back. And then I would love to be able to put this on the top. The words. Unfortunately, I don't think I could do that. All right. In that case, let's just make it into a section. Actually, this is not. Is this a section? Sometimes I forget. Section. Shift S. Shift S. There we go. That's what a section should look like. Let's hide those tools. Rename this section. So this section, run, does these things. Now we're just gonna, and then this comes back into itself. I do think that they have a different legend for that. See, this is why I want to put everything into Figma, because sometimes when you zoom in, it doesn't zoom in as you want it to. Okay. Callback, internal function. Okay, so that's how we may or may not follow this. The legend rule. Okay, so let's do this. I'm going to do this. Update. And I'm going to explain to you I guess you could do that. Or let's okay. I feel like this needs to be a different shape. Can I do that here? There we go. We're gonna keep everything the same color at this moment, at this juncture, because if once we want to change the colors, I feel like the color coding it should mean something. So okay. I kind of want to put this here, this here, this here. That makes more sense. Okay, and then these seriously need to be thicker. Thick. Black. All right. And then this could come up higher. Yeah. So we now have this part into this. Now we're gonna look into IApp interface, the app interface. We'll just call it the app interface from now on. And expand on this chart, because this chart is going to be bigger. Let's see if I could just drag this. Okay, great. I could just drag the top of this. So run, and I'm pretty sure that run probably shouldn't be the name of this section. Run is one of the function inside the app interface. Let's find run. Follow me. Okay, here we go. So I might be wrong, but I could see that this feels a little bit like a constructor. It's been a while since I coded, but it feels like that now. So I'm gonna pull this up here next to me. So I'm gonna apologize for all that cough, or that'll come in a little bit. But you know, this is the nature of today's situation. I want to learn, but I'm having a little cough. Okay, great. So run is here, and what run takes in is a whole bunch of essentially some initial values, and it calls it description, I think. Right here, we're looking here. I wish I could click on it. No, it looks like this if I click on it. Basically, what you're seeing here in this black background is sort of like a graphic, and then the real code I actually put into this box. I wish I could also expand on this box, which I cannot. It is unfortunate. Can I expand on this? Nope. Double click doesn't do anything. We'll just look at it. Look at it as so. Or we could do this. We'll just do this, actually. We're scrapping this. Oops. Scrapping this idea. I'm going to leave it. And then make this half size. Close U. Drag it to the side. As such. And then we'll do this side by side, like how we did before. All right, here we go. The terminal, because we're not going to use it. So here we have sort of the definition of what is in app descriptor, and it would include your app name, your app path, and some arguments, some integer arguments, some character arguments. I think like that's loose enough. That's extremely loose. So for real, you just really need to give it a name and a path. Excuse me. Let's see. Yeah, carb application name. Excuse me. So carb, what I've learned is short for Carbonite, and it's associated with C++, and it allows for, actually I did Google that. What is Carbonite in Omniverse? Let's Google it again together. So the Carbonite SDK is the foundational software layer for Omniverse applications. Microservice tools, plugins, connectors. Carbonite SDK provides the following high-level features. I don't know what the ABI stable interface means. Let's see what happens if I click on it. Okay. Okay, so it's a I guess it's a standard on the interface. I'm curious, so I'm just going to click on this ABI stable interface. What does ABI? Okay, application binary interface. That makes more sense. Okay, that is smart. Basically, anything that goes into the Omniverse universe needs to follow. If it's C++, at least, it needs to follow the standard interface in order to keep a certain level of quality, and then and predictability and such. So I will include these links. I think these are important things to understand, even for someone that's just coming in to create an extension. I think these are standards that Omniverse has most likely thought long and hard about to put it in a foundation, as a foundation for future developers in order to make scaling have quality. Because scaling, if without all these standards, you'll get into a very messy situation. And that is the lesson that PHP has taught us. Story for another day. We need to understand that. Let's come back to this. Okay. So the run loop, this is interesting because this run loop, oh, I wanted to say something. I remembered that I needed to say something. Let me pull this duplicate this, and I want to pull this on the side by side. So this will be interesting. In the documentation, at one point it mentioned a loop runner, which I believe is another thing than app run, but it's what did I want to say? Oh, there's a hang detector. I believe this is running if else determination. Yes. App it, yes. Now make this huge. Maybe not that huge. Just no. Like so. I believe this hang detector equals is running. Periodic nudge, if no nudge for a while, notifies user that they can shut down, crash the app, and report with a crash log dump. So that part, the can shut down, crash, report with a crash log dump will be included into this shutdown sequence. And the hang detector is the is running. And if so, if is running, update. Now this, it is not clear to me at the moment if the is running / the running basically what is equivalent to the loop runners. And I have a feeling that this loop might be the loop runner. So the hang detector is also the loop runner, which in the loop runner we had it marked down as drive the application loop, which is what it seems, pushes update events into corresponding updates. So within this update, we're going to be dealing with event streams. And in general is like basically a stack, first come first serve. Is it first come? Yes, first come first serve. And then or you could pop it up from the top. Is that how it works? Well, no. Scratch that. I think it is first come first serve. It essentially pushes things through a process. And these things could be our events basically. All right, so that's a little note over there. So let's run it through. If we go into app interface, and then let's find the run. You throw it in, you throw all the descriptions in, and once it's in, is running. We go through the startup. So let's find startup. Startup is here. You also need to throw in a. So this at this point you start up is considered you're starting up the application. You also throw in your description as an ID. So this, yeah, I think it is an ID. I guess it makes sense because you can only have one app, maybe one app under one path. It's a one-to-one relationship, I guess. Or you could just call the startup directly. I think you could. And then we have the update here. Is running here, shut down here. So it's really simple, actually. If you think about it, there's only like 4 things that it's on a high level. That it's doing on a high level. Okay, so once we're in, let's look at. Okay, so there's a. As I'm going down the code of this, let's pause on jumping around and then actually look at it line by line a little bit because I want to see who the players are. Now, that is also in this file. We have a run. Well, it's an interface of a loop runner, and it's interesting how they named this thing. So there's the extension manager, which we mentioned before. There's also the loop runner. So if this is IApp, or this is the app interface, we should probably give it a title. My app, application, app interface. Nice. That's what it is. And then we also have, I'm going to copy this. We also have the extension manager. Now the extension manager is under Omni, which is interesting. I think it's under Omni. Yeah, I think it is directly under. So when you use this, I guess when you reference this, this is Omni. I'm just going to put a note here. It'll be like this, ext. And then you start the kit. So the extension manager is outside of Kit, which makes sense because at one point it did talk about app as if it was extension-like, except it's the, like you could have, I'm guessing that you could have one app with one extension that is nothing more than an extension that also has an app name to it, like the app name, the app path. A bare minimum app will be that it may have one extension, or it may, I'm guessing that it could actually have 0 extensions. So I think I'm going to put this on top because I feel like this sort of more represents that. And then this is omni.kit. Kit. Like so. And based on its naming convention, I would imagine the extension manager is not an interface. The loop runner is an interface. And the app IApp is an interface. So there we go. And then we have, so I would say that this description sort of explains that. And then omni kit dot didn't have a namespace to it, or it didn't have I run loop runner. So this is equivalent to a loop runner. I'm not going to repeat it. It's just, if there's something that's not entirely clear, so, well, actually, you know what? Let's just do it. Loop runner, excuse me, interface. Because we did it here, so I'm just going to do it here. I'm going to make this font slightly smaller. Whoa, too small. So it's like a description of what it is. This is a subtitle, basically. All right. And this actually is like this. Okay. Do I need to say extension manager? That would be stupid. That's so redundant. All right. So if it's not clear, I do want to like sort of reinforce in my head at least. Anything that starts with an I is an interface. So I'm just going to write this description down here. All right. Now, did that, we did this, and then let's do some. So what does a descriptor look like? I'm just going to push this down here. So now we have a kit. Descriptor. Tour. Like that. And this has a, so simple. Love it when it's so simple. So you have, oops, name. And I do like that there's a, I wonder if there's like a non-carbonite app name. Maybe it needs to follow a certain convention, naming convention. So that's why they named, I guess that's why they specifically named, that's not what I want. Don't like that. So you need to have those two. All right, I like that. At least it sort of tells what things are. Build information, same thing. Wait, something's wrong. There we go. Yes, no, it's right. Okay. Build info. So this doesn't happen until build time, which makes sense because we didn't have to include that in the constructor in the run. Build info. Excuse me. I love these descriptions, these comments. All right, so down here, version short. So I can see why the logic of why they've made the extension advanced page look like what it is, because in order to there's a lot of naming conventions as well as practices, coding practices that should be followed, and I'm glad that we're doing this right now, because Kit, anything that is under Kit, will have a different level of standard as far as coding wise, compared to something that is under a Carbonite standard. And I'm sure Python standard and C++ standards are different. Kits, I would imagine, because we have the C++ part of the kit, and then we also have the Python part of the kit, but a lot of people write their kit extensions in Python. So you, that is a developer, should be aware of these standards. And I think that, documentation wise, it'll be interesting how we could put certain coding standards side by side with with the documentation itself, and how should we do that. And in fact, if we do that at all, it should be both inside an SDK development, where it quickly detects that, oh, you're out of the standard, or something is not in the right format. It picks it out for you, and you have to fix it before you could actually upload it or include that into this. But getting back to what it is, full kit version. So the advanced page also talks about version numbers, how it should, what standard it should follow as far as those numbers. But that's also here noted inside the code. So that's one of the things that is a schematic, basically, a schematic of how you name things and what certain info should include. Now we're on to platform info. So a platform info. Platform. So I'm guessing this also happens in big time. But I'm gonna remove that because it's not saying it in the comments. That's right. Now, so the platform info should have a config. And the config would be either debug or release. These are very, very basic information that one should be aware of. I'm just going to copy this. And we get the gist of it. I don't think I need to list everything. And then the last thing is Python version. So platform, I guess you always have a Python version when you're working with platform. I don't know, but I think it probably does because it's so ingrained in how the kit was built. So you always have a Python version. And then also you could swap out. I guess you could change the Python version and test it out by simply changing almost like a config setting here. So that you make sure that, whatever version people have, at least they know like what this is, whatever this piece of code it has been tested on, like what version of a Python it was tested on. Okay, now next, app info. So this is more, wait, we just did this. Did we do this? We did not do this. Okay. App information, basic configuration of current app run. Okay. All right, so my suspicion is right, because app info includes a little bit of all three things here, actually. It includes the app description, build info, and platform info in here. So, which I thought was very interesting. It might be a little confusing as far as like app info and app descriptor, but it might not be too, because again, I'm not an avid coder. I wouldn't call myself that. I've seen people when they code, they get so happy. So I know I'm not that. Let's copy you and put in app info. Now this seems a lot looser than what app descriptor needs, because just by how things are being named, I know if something that has like it's out of the ordinary of how it was named, it probably means something. Like you have to follow the Carbonite standards for this carb app name and the Carbonite standard of carb app path, I think. That's sort of how I'm guessing. Let's see. Okay. Basic configuration of current app run. Comes mostly from Kit file and other settings. I'm going to copy this. I think this is like really simple enough for people to understand what it is. So you could see that a lot of things, I'm really not, at this juncture at least, it's not really like creating a diagram of the workflow. It's really just acknowledging what things are. Let's see. Okay, so I'm starting to realize something. Is that the Omniverse has its own definition of what a string needs to fit in format-wise. So, and that also will become relevant because there's also the Carbonite standard of what an event would look like. So we have to, you know, I do think that it is worth looking into of what an Omniverse definition of a string will look like, because I'm sure it does some cleaning up, make sure it follows certain rules. So we'll look into that later, hopefully today, if we have time. Hopefully we have time. Sure. Is it important to note it? Do I want to? No, I'm not gonna put it in. So we're just gonna put this file name, version short, environment. Again, this is very similar to all these app descriptor, build info, and platform info. Environment, and is external. That's interesting. Let's see. Okay, let's go through this. Application name, file name. So this name could be anything, I think. And this is the name that you give it. Like when we just created that little extension example, we named it Omniverse from scratch dash wall, I believe. I think. Oh, that was the name, not the file name. But the file name, let's see. The file name could be just Kit. I think because the Kit, it's okay. A name is basically what we recognize as a almost like an app name. The file name refers to an actual, not the path itself, but the end folder of that path, what that name is, I think. So app name, it is app/name setting if defined. Otherwise, it'll be same as file name. Gotcha. So the file name could be defined or not defined. And if it's not, then it'll be the same as name. Okay. Version, self-explanatory, you know, it is what it is. Version short, that's the short version of it. Environment, name of the environment we are running. Okay, so this is actually different from platform environment. This is app environment name setting. Team, city, launcher. Oh, okay. I gotta look up what ETM is. ETM, what does ETM stand for in Omniverse? Oh, look, this also is inside the documentation. That's funny. What is ETM? ETM is also here. If anybody knows what ETM stands for, let me know. Just curious. Let's look into. Okay, I see. This is the this is the API doc. This is cool. I like that. Okay, so we'll go through this later, and let's move down the road a little bit. So, okay, we got another class called RunLoop, which in here, RunLoop is different from the iRunLoop runner interface. So this is the, it's hard to say what it is actually. RunLoop contains various event streams pumped every spin of RunLoop. Okay, we will create two. I'm going to put all the sort of struct here on the right hand side, and all the classes will be here. Shift S, classes, and then Shift S. This will be all the structs. Okay, all right. We have some organization going on. Now, next one, RunLoop. This is RunLoop, not an interface. Loop contains, and I'm writing this down sometimes fully understanding, but sometimes not. Contains various event streams pumped every spin of RunLoop. Let's look deeper into what it means. Okay. So these I could almost pre-update. Events pushed every loop, and stream is pumped. So this is a procedure, basically. It's not a dispatcher per se. It's like a, I don't know how to describe this. And I'm assuming that this happens like in sequence too. But a RunLoop will contain, do this, pre-update, like that, update itself, post-update. So you could basically add actions into these, I guess you could, into these procedures. And then you definitely need to have a message bus to, do I need to tell you what it is here? Stream for extension to push events. Okay, so this is what is being updated, I think. Okay, cool. Okay, and then within these, there's a few predefined loop names, which I think is so interesting. Main, simulation, rendering, UI, and present. So it's all about like procedures. Again, I think like going back to that chart of here we go, of what a kernel does is it sort of shuffles around who has the baton at the moment to run things, who has the resources to do things, and what state we're in inside the whole procedure. It's a project management thing going on. Okay, so and all these event streams is like, if we equivalent it to the real world, these are time events happening in time. So now you're mapping out the real world in the code. Let's see. I will. Are there two things here? How should I note this? Now this is not a struct. This is some, what is this in C++? It's a specifier declares that declares it that it is possible to evaluate the value of the function or variable at compile time. Okay, I see. It's like a placeholder for something that you could then define at runtime, but it's there. You know that it like these are your options. Okay, so this is not a class, obviously. This is, I'm gonna put it right here onto the side. Excuse me. And we are within Kit. I believe we're still in Kit. And then we have RunLoop default equals main. This is so interesting. See, these are presets. Okay, loop simulation. and then you have the loop rendering. These are the things that usually would happen when an app starts, basically. I'm having the feeling that you could have it happen or not, but it usually happens. Present. So there's usually an AI, usually a UI, usually a present step, and then there's usually a rendering step where you have to load up all the rendering tools and whatnot. Okay, so this actually, I will put this under, it's not really a class, but it's predefined loop names. Will we call it a class? No, it's just a placeholder. It's more like a struct than anything else, I would say. All right, now we have another class. I'm gonna still put a little block over this. Predefined RunLoop names. It's like, oh, I see. It says it serves as a hint, doesn't have to use only those. Serve as hints, doesn't have to use only those. So thoughtful. All right, now the next class, iScripting. Just use this one. Very good. I forgot to add a little comment there. It's the app scripting. Now the reason why, let's see. So that's it. That's all it is. An empty class, or at least as of now. App shutdown. So these are, let's see, predefined events that happens. So you have the event type, or rather you have the post quit pre-shutdown event type. This is interesting. App shutdown event pumps into IApp ... get shutdown event stream. Oh dear, we're gonna have a storm soon, it would seem. Get startup event stream. Let's see, app startup event pump into. Okay, I see. So when we do run the app startup, these are the two events that would be injected into the event stream. And then when it's shut down, these are the two things that would be shut down, that would be pumped into the event stream of the shutdown event. I think, right? Yes. Post. This sort of hints on post quit. So you've initiated the quit, and then this event type, the post, basically you finish initiating the quit event. So it turns into 0. And then it goes to the next procedure state, next state of the procedure, that's called pre-shutdown event. So it sort of hands over the baton. This is the act of handing over the baton from post-quit to pre-shutdown. That's my guess. And then this tells you that, and I almost feel like this is actually, I'm not quite sure if, it eventually will be changed into something more like this, where it's more readable as opposed to 0 and 1. But I'm guessing down the road it would be updated as such. And oftentimes we have placeholder for things that are turned on and off, but for readability, for scaling, really, it's actually a good practice to have hashes like this that are very clear of what it's saying in languages that people can read, such as app started or app ran. So this is actually, let's see, does it actually execute here? Probably it does. This is actually ran. This isn't, maybe it's inline code. I'm not sure. Excuse me. So let's see how we should put this into the script here, or into the little box. Let's see. I'm gonna do this, and then this is carb. I'm just gonna copy this, remove what is not necessary. just going to remove this. Arg. And then Shift S. So this is in something app shutdown events. I'm just going to copy this. I think these are a little bit, again, being really nitpicky about organization. This is highly, it's like a good to have, definitely good to be guided to, but I don't even know if I would put it in the code here like this. But hey, who am I to say that? I am nobody. Okay, click on this, align. I like things aligned. If you haven't noticed, let's just widen you. Okay, copy that again. And then obviously I think like this needs to be on top because startup comes first. Probably doesn't matter because this doesn't get executed until build time, I think. Right. At least the top one doesn't. Let's see. Let's make this a little smaller. Smaller? There we go. That's very hard to read. I'm just going to do this. There you go. All right. So for the sake of organization, I'm going to put the start on the top, shutdown on the bottom. But these are the things that happens when startup happens and shutdown happens. I am very fussy about this. I'm sorry, but it is very hard for me not to organize this while it's happening. Almost can't function. But what's good about documentation is like this is you want to organize as you go. All right, here we go. So we've marked that down. Let's come down to IApp or the app interface. I love the app interface. So here we go. Excuse me. So let's give you a different color. Should I put you blue? Let's put you blue. Because this whole thing comes in here. Is this? Yes, it is. Okay. Sure. We need a lot of space for classes. I'm going to put you here for now. And this class is going to include the whole IApp class. Here. So lovely. So inside IApp, as we mentioned, there's a startup, there's the running, there's the run. First of all, there's the startup, the run, the is running, the let's organize the thought. There's the run. When it runs, there's the startup that is running, the update, the shutdown. That's it. That's the all four of these parts of this API or this interface. I guess it is an API, right? It's an application. What was the full term of API? Application programming interface. That's exactly what it is. That's funny. And then we have the coding interface. Okay. So let's add these in. Actually, this is nice. So post quit. Let's see. Would this be in quit application? Doesn't quite quit immediately. Signals that application should be finished now. Okay, let's organize this. Is there anywhere that it talks about the shutdown procedure? It doesn't tell you the procedure, but it tells you that it's there. So let's block out all these existing procedures, and then we'll organize the sequence of them, how they when which happens basically. So I'm gonna copy you, paste, so we have something. We'll just have it floating around for now, and then eventually we'll sequence everything. Okay, post quit. So that exists. Then we have get log stream, get log event stream, which you could do. I'm pretty sure it's only going to happen when you do it. It's not part of the standard procedure. We should probably give it a different color because that yellow. That's too shiny. Let's give it a white. Is that too? Let's see. Like that. Okay, that's okay. And then we have replay log message. Replace recorded log messages for the specific target. So these only happen really when you call it. So I'm going to put that there. And I'm going to put you down here so we have more. Toggle log message recording. Put that there. So there's a lot about messaging in here. I'll make this longer. Yeah. Delete you. Unfortunately, we don't need you anymore. And then we have the get run loop. Get run loop. Is run loop alive? This may or may not be part of the procedure. But I'm going to make it as a blank first before we put it in. Once we put it in, it'll be blue, basically. And then you can do this. You can terminate. Okay, so a run loop is different from running. Run, basically. Run loop is a specific thing, I think. And it has to do, it would be under here, under like, essentially it's a smaller scale thing, if that makes sense. It's part of an event, I think. This is my guess. I might be wrong. Okay, now we get into pre-update event stream. And then get update. Oh, interesting. So you have a pre-update, and then you have the update, and then you have the post-update. So you have all those stages. How should I do this? So by that, we already know that there's a pre-update, there's a post-update. There's a pre-update. Well, this is actually not a function per se. This is, we'll have to figure out how to do this, how to mark this up. Let's finish up what we were doing. Focus. Finish it up first, and then we'll get to it. Then we have the get message bus event stream. So I'm going to pull out things that are highly related. Like these are all about the update event stream. And then these are all about the loop, run loop, sorry. Oops. These are together. So, and then we have the log messages. Like so. I'm just going to really, it's like organizing paper. Okay, set. So gets message bus event stream is just one thing. And that is equivalent to get run loop. Okay, so it's just a different name. Oh no, it's actually saying that it's a non-specific message bus. Arbitrary client push to it. Application pops it once per frame after the post update. Fascinating. So it does happen here. This is sequential. Is it? So we handle the log first. Toggle, get run loop. Turn on. So instead of doing this like that, it actually makes more sense to say that this happens after that, this happens after that, and this happens after that. Okay, so we are like sculpting out the general skeleton shape of things right now. Okay, so get message bus event stream. Where are we? Oh, I see, I see. So this is it actually. This is the pre-update. So we have I'm going to remove these brackets because I want to not indicate that it's always a function. And it might be, let's see, it might be just a state change. Yes, so pre-update, and then that. And then this comes down. This could go update. Then we get the post update. Post update. Yes. Like so. We'll organize this chart later, but that's what's happening. I'm gonna shrink this a little bit. So let's follow this through because I don't want to accidentally miss something. So we did the terminate run loop. We did get free update event stream. Get updated. So this is basically getting this, and then now we have the this is just a general. We do this get post update event stream, and then here we have this get message bus event stream. This is just a random. It's not really sequential right now at the moment. I think. Is it run loop name message bus? We're just getting something, and then let's see. The next one would be set run loop runner. Okay. So maybe related, maybe not. I'm just going to give it a little space there. Set run loop runner. So I think this run is the loop. So I think it's being used interchangeably. Okay. Continue. Get extension manager. Get Python scripting. And then get build version. These are all like really getter and setter things. I mean, you set the moment you sort of create the app. Oh, let's see, is debug build. So this is all getting all those descriptors, the information, get platform information, get time. This is so helpful. Lovely that it's written. And then get last update time. Get update number. So I'm listing these out because I do want the chart to be complete, but it doesn't really have a sequential like place of it. It's a triggered driven function, generic function to output message target for developers. Print and log. Oh, it's so helpful. Shutdown event stream. Get shutdown event stream. So I'm going to put this even right, a little bit to the right from this. It's because I know that this happens close to last. Try and cancel. This is a different state. And I love how they, and this is really, and again, I think like thinking about this like an operating system is why it makes sense, because it's literally running operating system stuff. Post uncancelable quit. So if it's uncancelable, there's a post, there's a, okay, so this basically it's if cancel is unsuccessful. Again, they put the startup last. Actually, it's so interesting. Get startup event stream. They put the startup after quit program. Maybe because they wrote the startup first and then added, I don't know, who knows, is app ready. These are really simple getters. And delay app ready. This is interesting, delay app ready. Let's read it. Use this function before the first update to delay, excuse me, Kit event app ready until the next update. So you get to, you have the choice to delay it a little bit. I think they mentioned that in the manual as well. On the first update, app will be considered ready unless it was delayed by explicit API call. It can be delayed each update up to infinity. But eventually, when not, it would send ready event and switch into ready state. Gotcha. So remember how we did this? We marked out, where are we? Here we go. So they basically did push 2 events into the event stream. First, they pushed in app started, and then they pushed in app ready. Now, if you sort of specify to have a delay app ready function run, it could delay a certain amount of time and then switch to ready. And if you don't do that, it'll just, by default, it'll just go from start to ready, back to back without pause. Okay, that's interesting. That's such a, it's a very specific thing to, I guess it makes sense because starting, ready implies that it's waiting for the next step. Start implies that it finished starting. Does that make sense? Yeah. So logically, there are 2 different things, but sometimes they could mean the same thing, and that's why you have the option to delay the state change. Okay. So lastly, we have the get build info. We have the get app info. These are very, very simple getters. That, excuse me. So I guess at this point, so these are all the functions that I want to organize this a bit. Let's see. More so, I want to space them out equally. Is there a way to do that? Plugin widget, maybe not like this. Huh? Is it this thing? Oop, that's not what I want. Oh, let's see what it is. Object, arrange, tidy up, align. I guess I could, oh, here we go. Distribute vertically. There we go. That's what I want. And these are all inside IApp or app interface or API. They're all the same thing. How should we put this? Okay, there's something here. So I'm gonna remove this. Oh, that's not what I want. Let's pull this out because run is not including all this. Run should not be here. Oh dear. How do I detach them? Yes, so it's still attached. Maybe I need it to be far away. We are having a storm. We are having a storm. So let's see. Okay, now it's detached. So I am going to put this in here. And as you could probably tell, there's going to be there's startup, there's ready. So you go to this, come down, get ready. Ready. Such, right? And this is related to, why is this grouped together? Did I ungroup it? Oh, it's not a group, just an accident. Okay. So we know that start, ready. And I do need to eventually find the sequential, like these look like getter and setter, but I think there's a procedure, there's a place where procedure is written. Yes. All right. So before we get into the iScripting class, I do want to come back a little bit into, excuse me, into what these all these mean, basically. So we know that there's the startup. We know that there's run. So run happens first. Because it says it's an inline helper to startup, which means that we're running run in order to start up. Okay, and loop and shutdown. So run. Now inside the runner, which is in here, can run. Postquit is probably down here. So there's the beginning, there's the end. What's happening again? Okay, definitely something. What's it pulling along? Not quite sure. I'm gonna delete you. Make another one. Make a clean one. Let's make a clean one. Post quit. Definitely not in here. But this will be post quit. Is quit equal to shutdown? Not sure. Okay, here, let's read this. Quit application doesn't quit immediately, signals that application should be finished now. Okay, so quit happens before shutdown. Because it tries to quit first, right? So let's, I'm gonna remove this, put it here, this, post quit. So let's quickly go down because we just read it. We just read it. Try cancel shutdown. That's what I'm looking for. Try cancel. So this whole part. Get shutdown event stream. Try cancel shutdown. Post cancelable quit. For these two specifically, actually. That's what we're looking for. I'm gonna change you into a blue. Cute little blue. Remove this. So if post quit, so quit indicates or implies that the user tried to quit or initiated the quit request to the app, or something's not running right and the system tries to shut down. So that triggers a quit, I guess, initiator. Now it tries to, wait, try cancel shutdown. Request shutdown interruption. Oh, this is different. Post. Well, I guess, so I guess we can't do that. We can't just simply move this over. Because this is different. This is trying to cancel the shutdown. This is actually triggering something. No, trying to interrupt the shutdown and post quit. So, excuse me. So we have a post quit, and then we also have a potential state where it's uncancelable quit. We'll figure that out later, I think. So at the moment, I'm still gonna put this back. I know, I really want to finish this chart too. Okay, so I guess at this point, I couldn't do what I wanted to do, but let's finish up this file first. Let's finish up marking out the scripting, basically reading through all these lines. Here we go. Scripting events. So there's, here, you could, this sort of reinforces what I was trying to say, where instead of having 0, 1, that sort of turning on and off as far as event states, it's actually good practice to have readable state name changes. And this is basically what that is. This is like, there's going to be 3 states. One is a script command, one is script std out, and then one is std error. So these, they're using 0, 1, and 2 as at the moment, but maybe in the next version of Kit, we're going to see this change out into readable state changes. But to mark this down, coming back to this, where should we put you? IApp scripting. Sure. Did we see 2 IApp scripting here? 1, 2. No, this is not. Okay, I see. So at this point, this was completely empty. Now they're writing it out. So let's simply do this. And I think these will probably be essentially these are actually also struts. Oh, I don't know if you would call that strut, but let's just put this in here. And this will be, put this like that. And then move this. And I'm probably going to leave it as a comment, but that's pretty much, it's equivalent to this, basically. These are the possible scripting events. Scripting events. That's into IApp. Does it? That just happens. Event stream. Making things up. Switch back to using string hash when fix for event stream push by is merged in from Carbonite. Understood. Yeah, so this is not too far off. All right. So that's marked. Let's go back to the app scripting interface. See what that does. So let's group all these guys together. Group you. But whoop, I guess I do need to include you. And pull it down like such. And then group you. So I'm gonna whoop. Darn it. Wait, is there two? There might be two. Nope, it's there. For some reason, this isn't coming in. Yeah, there's only one. Allow. Does that work? Yeah, this line doesn't want to go in. Not snapping to it. I feel like this is a bug. And I'm just going to do this. All right, that's all I wanted. Okay, let's look at scripting. See what happens. And okay, so inside, let's see, scripting engine part of application. Run script from a string. Content of a script to execute. Command name. Execute as file. This is so interesting to me because this is exactly the same as how if you run script in an operating system command line or in a command line in an operating system, this is like this is how simple it is. It's like you have a command, you have a command, and then you have the variables, the strings that's attached to it, and then you have potentially interact with files. That's all it is. But these are, let's see, so we need to attach this. That's gone. This comes down here because this is together with that guy with app. And then we have these guys up here, which is execute string, simple enough, execute file, and then we have add search script folder. Interesting. Sure. Remove script search folder. Remove search script folder. Let's see what it says, and then get it event stream. Okay, so these are self-explanatory. Run script from a file. Return true if execution was successful. That's easy to understand. Add search script folder. Okay, so this, I'm imagining that this is all the commands that basically this is our bin folder if you're on a Windows or actually Unix also is called bin. So this is all the executable commands, the folder that holds those. And I'm imagining that you could add more folders as a search path in order for it to find what you could execute. Script event stream, execute of script produced, right? So every script, when it runs, you also have all the state changes. Event stream, and this is helpful when you treat commands as if they're that are events in an event stream. This is helpful when it's like when you're doing a remote thing, like say you're connecting to a server, either it's local or not. I'm sure it also is helpful when it's like through different apps, so you could pass things back and forth. Let's see, and that's about it. Let's see, this is this guy. So how should we organize these things? It doesn't necessarily tell us any sequence, but it does tell us what is in there. I suppose this is similar to these guys. Okay. Now, I want to use this class to pre-update. Yeah, this is actually explaining, this is the loop. Pre-update, update, post-update, and then message bus. Now the message bus is probably, to me, it sounds like a, what do you call that? Like a payload. Let's go back to RunLoop and go start try to understand this. Run. What do we have first? Here we go. Not runner, RunLoop. And then we have it here. Okay, so this is me understanding this. So this is the RunLoop. Now message bus, as said before, stream for extensions to push events to. I wonder if the pre-update, update, post-update, if they pass the message bus around, or is message bus like a global thing as far as within the loop. But it doesn't matter. It exists within the loop. So I was almost tempted to put a little box. Oh, didn't need to do that. Put a little box around this loop and call it the RunLoop. RunLoop. And then we have within this RunLoop we have the oh, I didn't like that. Let's give it a different color. A little mucky now. And then here we have the text, a piece of information that's called the message bus. So we're gonna eventually, I'm just hinting that we're gonna actually go into event stream, the classes, and sort of study up on what everything entails, and the exact procedural place of what everything is in. I am tempted to continue this. But I think what I'm going to do is I'm going to pause the video stream right here and leave this half done, but at an important, at a good place. We finished reading up this IApp app interface C++ file, and so basically we are sort of done to some extent at this point. Get log. This is actually here. Nope, didn't mean to do that. Or rather, let's just do this. Let's take it. You. So now everything has is here. I think we're gonna pause here and let's see. And little indentation is just really an indication that these could be in its own little group. We're just gonna visually have a separation between those two, different things. This one here. General things, shut down event stream. I feel like this needs to be up here, and then where were we? Get startup event stream, get shut down event stream. These are all related to event streams. Should we put it all together? I'll respect the sequence of how it's laid out right now, and then until we have more information on where exactly things are and what are the sequence of things, and then we could probably put them into place in a more solid manner, because I think like this is me guessing based on their naming conventions. So I don't think that that's a good enough reason to move things around in a chart. But as I'm looking, so we finished this file. Let's really briefly, I know we sort of spent a lot of time, but let's really briefly look at the Python version of this, sort of mapping things out. And I really like how everything is in one place and sort of more condensed as far as code wise. So this is almost, I'm guessing that this is all the events states that we could put into the event stream, or that if anybody is subscribed to this event stream of an app, these are all the different states that it could be in. Now there are some things that are not all caps. I'm guessing that they have things to be completed in order for it to, like, once things are, I'm not quite sure why there's different conventions here. I'm not sure. People, Omniverse team, tell me. I am curious to know. But this has a really great it has a little bit more functions than what the C++ have, mostly Python related. I love how all the, like, whenever there's like a pattern that I could follow, it's much more easier to read, for me at least. So we have delay app ready, which we also have one of those here. Do we need to show? We don't need to show. I feel like you all still remember. Get app, get file name, get app name, app version short. Those are the simple things. Build version, extension manager, which is a class interface. Not an interface. It's a class. At this point, right here, get extension manager, and then kit version, version hash. Gotcha. I wonder if this has that. I don't remember. I don't think it does. But it has it for the Python version. Get message bus event stream. Yes. Python scripting. This is not in the C++ version. And then shut down event stream. Excuse me. Startup. Get time since start which we have. I like that there's a millisecond version. There's a second version. And then update event stream. Okay. Is app external? Is app ready? Debug. Build. All of this has an equivalent C++ function. Post uncancelable. Yes, this is all noted. Reply log message. Replay. I'm sorry. Replay log message. Did we have one of those? I don't think we did, but it does have. Oh, we might have that actually. I'm just remembering. We have the print and log. So I'm not quite sure if that's the same thing. No, it's not the same thing. Print and log is print and log. Replay log message is replay log message. I don't think there was a replay here, but there's a run, there's a shutdown, there's a startup. Toggle log message recording. Fascinating. So we could record it like a stream, and then we could just try cancel shutdown, update, and the stuff about scripting. Add search script. These are exactly the same. Get event, remove search script folder. Those are exactly the same. Acquire app interface. Acquire is a very interesting word. I'm not quite sure why. Not quite sure why. You would think that one would, use get app interface, but maybe you can't get it because it's an interface. I'm not quite sure. People that are good at Python or Omniverse, let me know. Crash, understandable. Okay, so these are actual functions that they wrote down, I think. And then we have, let's see, all these. Oh, these are the default values, maybe, or the max. Not quite sure. Default values seems more like it. So these are, yeah, if not defined, this is the value. Okay, so we finished reading the app interface, and I am happy about that. I do want to, coming back to this one, I want to get into each of these things. I want to get into extension manager. I want to get into the RunLoop runner. So next episode maybe, or even I might just record it. Oh, I might do it right now, but I'll release the video later, and hopefully people are still interested, because I do see that it's getting over into becoming a really long video. And that's that for today. Thank you for joining. If anybody is interested in asking questions, I'm not sure how much I could answer, but I will do my best. And I appreciate Omniverse's teams a great deal as I'm reading through their hard work. And hopefully I'll be able to bring value to anyone that's watching this. But I am certainly learning quite a lot. So that's it for now, and we'll catch up later. See you then.